Hello guys, welcome back to my channel. Today I'm going to explain you how does BFS work and how you can use it to solve different problems. Last problem that I solved on this channel, I used BFS, and I think that it'll be great to explain to y'all how does it work. Um, so yeah, let's get started. Basically, imagine that you are setting your graph on fire, and then the blaze, it doesn't just jump randomly, right? So it doesn't go from vertex number 1 all the way to 9, just jumping here. It doesn't go like that, it doesn't work like that. It first, the ignition point burns like everything that is connected to the to the vertex 1. So let's say if we are burning this, right, so it will see what it is connected to. So it will be 2 and 5, and then this 2 will be burned, and then this 2. And then from here, 2 is connected to 3 and 4, 5 is connected to 6, 7, and 8. So it will burn this, 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 and then this. And then from here, 3 is connected to 9, so it will burn 9. And other things are not connected to anything. So yeah, this is how BFS works. Yeah, so in order to do this, we need So in order to do this, we need a queue. This is our burning front. It will hold um, our currently on fire verdicts. So yeah, and then a visited set will be um, the set of vertices that we haven't visited, so that we don't go to the same vertex twice, right? So yeah, now let's see how we can implement this on C++ language. So here I have my code logged, and yeah, let's start. So we need and m. This will be number of vertex, and this will be number of rows, right? So let's do this. Yeah. Now basically we need to know our rows. So usually in the problems on code forces and at coder, um they usually type in 2 vertices, and that means that there's a connection between these two. And then depending on the problem, um, they will tell you if they type in U and V, if that means that you can only go from here to here, or is the road like you can go here and you can also go here. So double direction. So we also need to have a set of all of the we need to save our rows obviously. So yeah. All right, so I'll create here a vector to like save our graph. So why did I do plus 5? It's just preference for me. You just do it, just in case, just if something happens, so that your code doesn't go outside of the vector. So yeah, mostly people do this. It isn't like that much of the problem. You can just put +1. It's also okay. Also, if you do +1 or +2, or it doesn't matter, if you do plus something that is not 0, and not negative number. Basically, we know that in C++, our arrays, their indexes starts from 0 and then goes 1, 2, 3, 4. And usually in the problems on code forces, here, so if they type in number of vertex, um, they do not, um, you know, subtract 1 in their problem. So instead of just doing this, I can like just put +1 here so that we just don't care about um, indexes that much. Yeah, and this will vary depending on your problem. Basically, it will say in the statement. You can just like scroll down and then see. I will show y'all later. Yeah. Also, we need a vector of visited um, vertices so that we don't check same vertex twice, because it will lead to infinite infinite BFS function, and which is bad, obviously. We'll put everything 0. So this if visited of I is 1, that means that we have visited. If it is 0, if it is 0, then we haven't. Yeah, so here, see like how here I wrote square like preferences. It is because we're basically creating an array of vectors. So basically, I have a matrix, but each of my um, columns, my bad, I meant lines, they have different size, right? So it can be like usual metrics would be like 3 by 3, right? And what I have here is it can be like this, you know? So each of my lines have different amount of elements. Yeah. So I'm gonna write this down for you. It contains all the elements. And you also need a queue to track what vertices we will go in the future. Yeah, so these are vertices that we need to check in the future. So here, when they type in u, sin, u, and v, what we do, we just push back v inside u, and then here. So the reason why I did this is because here I assume that when they type in that u is connected to v, I assume that that means that v is also connected to u, but it will vary depending on the problem. So if the um, if the roads are directed in your graph, it will just basically do this. But here, I'm doing a simple BFS. So yeah, I just assume that if U is connected to B, that means that we can go from B to U2. Yeah. Yeah. So now we can start. Wait, first we need to write our BFS here. We don't need anything here. I write BFS as a function, but you can write it inside your int main. It doesn't matter. You just didn't think about BFS. Yeah. So while so think of it like that. While we have customers to check, we are running our BFS, and then once we are out of customers, we'll just get out this get out of this while. So int v equals so q point front is our next customer, right? So that means that if we have a queue of people, q point front will tell us which customer comes next, right? So and then q point pop will delete this customer from our queue because we are already serving him, so we don't need to have him in the queue anymore. Right? And now from here we'll see all of the connections of each customer. So to do this we need to run everything. Here we will look at all of the connections of our vertex. So as I said, we need to check if our connection is visited already. So it will be so here we will be pushing our view inside Q and then just visited. Uh, so yeah, we're pushing our wait. I this and then here we also this. And yeah, this is our BFS basically. So now we need to look at all of our vertices and see if they're visited. So if we have not visited our vertex, so if visited for 0, we'll push it inside our queue, and then we'll tag it as visited, and then we'll run our BFS. Let's see if it works. Should. Yeah, it works. So yeah, this is the simple guide for BFS. So when do we need BFS? So it can be used for different purposes like finding paths on a graph or map. It can also be used to calculate degrees of separation, network analysis, and many more. It is limited, obviously, to your imagination. This is a good thing about competitive programming. Yeah. So thank you guys for watching this video. Make sure to like and subscribe. Also, if you still have some questions, ask them in comments. I'll make sure to answer all of them as soon as I see them. See y'all in the next one.